equipotential surface. So what is the equipotential surface? See, the word is equi means equal, potential, we know about potential, so equipotential surfaces. So what is an equipotential surface? An equipotential surface is that surface on which electric potentials at all points are equal. The electric potentials at all points are equal. So the electric potential due to a point charge is given by, we know that this is the relation V equal to 1 by 4 pi epsilon naught Q by R. This R is constant. V actually, where V, if this R becomes constant, this is say some distance or radius, you can say, V will become constant. This will be also constant. Now we can say that for a single point charge, say Q here, the equipotential surface are the surfaces of spheres drawn by taking the charge at the center. If you see this figure, the potential on which this is the center, and these are the, if you take a circle, all the points in the circle are equipotential. This is one equipotential surface. This is another equipotential surface. Let me draw another surface which is equipotential surface. So the potential on these or two or more, you can find any of these different surfaces are different, but for all the points on the same surface, say here, say here, say here, all the points on the same surface, the potential will be equal. So the electric field produced by, say, a point charge is along the radial, this radial direction which is drawn from it. If you take plus Q, they are in radial directions going away from it. If you take minus Q, they will be coming inside. So these radial lines, these are normal to these equipotential surface at every point. So at a given point, the direction of electric field is normal to an electro or so equipotential surface which is passing through that point. So we'll try to see that or prove that this is true not only for a point charge but for any charge configuration. Suppose we have a unit positive charge and we give a very small displacement, say dl, this on the equipotential surface, and we do it along the surface, say from a given point. If this in this process, the work required to be done against the electric field will be what? Work will be, if this is very small, we take work as also small, dW will be equal to minus E dot dl. Why this is minus? Because we are working against the electric field by the external force. So work done will be minus E into dl. This is the potential difference between these 2 points. But the potential difference on the equipotential surface is what? Any equipotential surface you take, the potential difference between these 2 points will be 0 because they are having equal potential. So this E dot dl will become 0. E dot dl is what? E dl cos theta. That means this E will be 0 either, or dl will be 0, or some cos theta, means theta has to be 90 degree, cos 90 is 0. This theta is angle between E and dl. So E electric field, we are saying it is not 0. dl, the displacement is also not 0, so it is clear that cos theta is 0. So when cos theta is 0, theta has to be pi by 2, because cos pi by 2, cos 90 is 0. That is why we are saying that this electric field is perpendicular to this displacement dl. This dl is along this surface, we have just disclosed that in the beginning. So the electric field E is normal to the equipotential surface at that point. So like the electric field lines, the electropotential surface is also a very useful concept in order to represent the electric field. For a uniform electric field, say it is prevailing in x direction, the field lines are parallel to x-axis and they are equally spaced. While the equipotential surfaces, for the equipotential surfaces, these are normal to x-axis. That means you can say it is parallel to yz plane. You can see here, these are the equipotential surface for a uniform electric field, right? If this is y, this is your z, this is your x. This is how the electrostatic potential or electric field you can observe. So this is the electropotential surface of a dipole. This is minus, this is plus, so they are equal charges separated at some distance. And this is just for information. These are equipotential surface of a system of two positive, or you can say these are positive or equal charges, only for information. So equipotential surfaces for electric dipoles are shown here. The equipotential surface for a system of two positive charges of equal magnitude are shown like this. This is a dipole and this is because they both are same charges.